Don't share any personal information for the safety of you and yourself and others. Keep your behavior, language, and webcam background school appropriate and respectful at all times. Know that your participation is so important. The more you participate, the more you get out of class. The more you get out of class, the better your grade's going to be, and the better the class is going to be. And I appreciate it so much. And then always remember that these Class Connect sessions are recorded and distributed for learning purposes. So today is Tuesday. It is Tuesday, July 15th. We are starting our very last unit. Okay. Our last unit is Unit 4. And that is what we're going to wrap up with. We have exactly 8 days left in the summer. And then we will be done. Hey, Jaden, so glad you could join us. So you can see Unit 4. We're going to talk about chemical reactions and balancing chemical equations. We're going to spend 2 days doing that. We'll talk about the mole and molar mass, and then we're going to shift gears a little bit, talk about solutions, solubility, acids and bases, and that will be the end. So our Unit 4 exam is not until next Thursday, not this Thursday, next Thursday. Quite a bit away. Today, we're going to talk about the components of a chemical reaction. We're going to explain the difference between endothermic and exothermic chemical reactions and talk about the types of chemical reactions. Okay, so go to your course page, your calendar page, modules, your announcements, and go ahead and open up notes for a chemical reactions. Okay. And did you know that baking and cooking in general is all about chemical reactions? And when to mix in acids, when to use bases, and how it affects your taste buds. All of that is chemical reactions. Pretty cool, right? Yeah. All the things. Perfect. Thank you, Australia, Danny, Randy, Lamont. Thank you, Ryder. I appreciate you. Michaela, Jocelyn, Jaden, Dulce. Ready? Got your notes open? Click OK on question number 1, and then we'll get started. Yeah? Give you another 30 seconds or so to get this done. Okay, let's do it. If you hear the word reaction, right? What do you think of, right? I know usually when I hear the word reaction, I think about like somebody reacting to something, right? Like a jump scare or being sad or being happy, being excited about getting your first new car, right? Typically, I don't think most people think of a chemical reaction, right? But really, it's just kind of the language of chemistry. I know we've got symbols that represent elements, and that's kind of the alphabet of chemistry. So I've got hydrogen, oxygen, sodium, iron, right? And then compounds, when these elements are bonded together, like H2O, which is water, CO2, which is carbon dioxide, NaCl, which is sodium chloride. Those are kind of the words of chemistry. And then when we put them in these chemical equations, right, where 2H2 plus O2 yields 2H2O, that becomes sort of the sentences of chemistry, okay? And that's how it kind of all gets put together. So a chemical equation is an expression that describes the changes that happen in a chemical reaction, okay? So question number 2 is changes. It describes the changes. Kaylin, so good to see you. Hello, hello. We are working on 4A chemical reactions. Just got to question number 2, so your timing is impeccable. Thank you, Jaden. Thank you, Michaela, Danny, Lamont, Randy. I appreciate you, Ryder. Jocelyn, Dulce, ready, ready, ready? Perfect. We'll wait another 20 seconds or so just to make sure Kaylin can have a chance to open up her notes and get caught up. Okay. Perfect. Wonderful. Okay. So a chemical reaction occurs either when elements bond together, when bonds are broken, or bonds rearrange themselves. And anytime that any chemical happens, heat is absorbed or released. Okay. So with any chemical reaction, heat is always going to be absorbed or it's going to be released. Okay. Here we can see we have 3 hydrogen molecules, right? And 1 nitrogen molecule. 2 nitrogen atoms are bonded together, and the bonds are being rearranged to form 2 ammonia molecules. Okay. Thank you, Jaden, Kaylin, Danny, Michaela, Randy, Lamont, Ryder. I appreciate you. Jocelyn, you good? Dulce, ready, ready, ready? Perfect. Love it. So if you look at these pictures, right, it is actually pretty easy to match what is happening with each one, right? So here you can see I have 1 molecule, right? And then at the end of the chemical equation, I have A and I have B, and they are no longer together, right? So obviously, right, that is going to show how bonds are broken, right? Conversely, if I do the opposite and I start with an A plus a B and 1 molecule gets formed, that's when a bond is formed, right? And then what's really interesting, right? If you look at this, here we have one molecule called A and B, and a second different type of molecule, C and D. And then what happens is they get rearranged, and now A is bonded with C, and we also have B bonded to D, right? So if I had to match these, okay, you could probably figure out which one goes with which one pretty easily, right? And this is question number, right? You're just matching what you're seeing in the illustration to the description of what's happening. Any one of those is a chemical reaction. What you're starting with is being changed, and it is very different from what you end up with. Thank you, Australia, Jocelyn, Jaden, Danny, Lamont, Michaela, Ryder, Randy. Thank you, Kaylin. Awesome. Perfect. Okay. So with a chemical reaction, changes occur. It it results in a different substance being formed. Okay. Remember, during physical changes, like if I take a piece of paper and I tear the paper, the molecules and atom stay the same, right? Nothing is being changed except for maybe the shape or the size, okay? Hello, Adrian. So glad you're here. Hello, hello, hello. We are working on our Unit 4A notes. So go ahead and get those opened. Okay, and if you don't remember where to find them, let me know in the chat box and I can show you how to do that. But we are in question number 5 right now. Okay, thank you, Australia, Jaden, Kaylin, Jocelyn, Danny, Michaela, Lamont, Ryder. Thank you, thank you, thank you. Randy, you doing okay? They'll say, doing okay? Okay, give you another 20 seconds or so and then we'll get started, okay? Awesome. Okay. So that was question number 5, right? So evidence of a chemical reaction could be a change in color, the production of gas, like if you see bubbles or you smell something new, okay? The formation of a solid, okay? Maybe transfer of energy, something gets cold or something gets hot. And then for sure, heat or light is a signal that a combustion has happened, okay? So I'm going to give you your annotation tools. I'm going to give you your marker and your pens and your highlighters. Select all of the correct statements, okay, for question number 6. I'm going to tell you that there's 3 correct statements. One of the blue statements is correct. One of the pink statements are correct, and then one of the examples is correct. So grab a marker, grab a highlighter, and tell me which 3 statements are correct. Do the bonds stay the same, or are the bonds changed? Do different chemical substances form, or do the substances stay the same from start to end? Okay. And then as an example, freezing water into ice or baking soda and vinegar forming carbon dioxide and sodium acetate, which is a salt. Yeah, the bonds are broken, formed, or rearranged. The example is baking soda and vinegar, 100%. Okay. And different chemical substances are being formed. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Yes, exactly. Those are the true statements about chemical changes. Okay. Thank you, Jaden, Michaela, Danny, Jocelyn, Australia, Adrian. Thank you, Lamont, Ryder. Randy, you good? Kaylin, Dulce? Thank you. Yeah, perfect. Okay, so with this, 2 new vocabulary words. Reactants. Reactants are what we start with. It's like the ingredients, okay? Products is what we end up with. So the cake is like the product, okay? The actual baking of the cake is the reaction, okay? So ingredients is the same as reactants, and then the cake is my product. It's what I made. Thank you, Randy and Lamont. Thank you, Michaela, Danny, Jocelyn, Jaden. I appreciate you. Thank you, Australia. Thank you, Kaylin. Thank you, Lamont. Adrian, you good? Awesome. Perfect. Okay. So a limiting reactant is when one reactant is completely used up. Okay. And when it's completely used up, even if there's more of everything else, you have to stop making cakes because you ran out of one of the ingredients. Okay. Thank you, Adrian, Jaden, Kaylin, Michaela, Australia, Danny, Randy, Lamont, Ryder. Thank you, thank you, thank you. Jocelyn, you good? Okay. So let's do an analogy, okay? An analogy is when I compare something to another, right? So let's make an analogy with this limiting reactant and making a cake, okay? So here's my recipe to make a cake. I need 1 cup of butter, 2 cups of sugar, 3 cups of flour, and 4 eggs. So I want to know how many cakes I can make. I have 4 cups of butter. Each one cake that I make, I use 1 cup of butter. So if I have 4 cups of butter, I could make 4 cakes, right? Easy peasy lemon squeezy. Next, if I have 10 cups of sugar, right? And the recipe calls for 2 cups of sugar. That means I could make 5 cakes with the amount of sugar that I have, right? If I have 9 cups of flour and I need 3 cups of flour to make a single cake, that means with my flour, I could only make 3 cakes. Okay. And then if I have 8 eggs, right? If I have 8 eggs and I need 4 eggs to make 1 cake, that means I only have enough eggs to make 2 cakes. So without going to the store, the only the amount of cakes that I can make is 2 cakes. And my limiting reactant is my eggs. I can only make 2 cakes unless I go to the store. And that is question number 9 and question number 10. Thank you. Thank you. Thank you. Thank you. Jaden, Australia, Jocelyn, Kaylin, Michaela, Danny, Lamont, Ryder. Randy, you doing okay? Thank you, Adrian. Dulce, you doing okay? Okay, dokie. Okie dokie, Pinoki. So I know exothermic reactions release heat, right? If I think about the prefix exo, that means heat exits, right? Heat exits. Endothermic is when reactions absorb heat. So heat is going to enter the reaction, okay? So with that, if I have an exothermic reaction and heat is being released, that product, whatever I am making, is going to feel hot. It's going to, because that energy is being released, I am going to feel heat. Okay. Conversely, endothermic, when energy is being absorbed, when that heat is entering the reaction, that's going to cause it to feel cold, okay? Because the heat is leaving the environment and going into the reaction, okay? Thank you, Australia, Jocelyn, Jaden, Kaylin, Michaela, Danny, Lamont, Ryder. Randy, you good? Thank you, Adrian. Okay, perfect, perfect, perfect. I have a video clip. And this is a cool reaction. Okay, this is going to be a endothermic reaction. Okay, so notice it's 21.2 degrees Celsius right now. Ooh, -6 degrees Celsius. And the water that he put on the board before that chemical reaction froze to the beaker so much that he could pick up 20 pounds of books. Crazy, right? So that was, again, endothermic. All of that heat entered the reaction, causing the product to become very, very, very cold. Okay. So here is question number 12, and this one is complete on your own. Define reactant and product, and exothermic and endothermic. Okay. And remember, you can go back in your notes and double check if you are not certain, right? Thank you, Jaden, Jocelyn, Danny, Randy, Lamont, Ryder. I appreciate you. Kaylin, Michaela, Australia, Adrian, doing okay? Yeah? Easy peasy, lemon squeezy. Perfect. Thank you, thank you, thank you, thank you. Okay. So that was question 12. Now, there are 5 types of different reactions. Thank you, Kaylin. There are 5 different types of chemical equations. And scientists, chemists that are use a lot of chemistry in their job classify these reactions in order to help them predict what they're going to make. Okay. So knowing how reactive elements are going to be and knowing how they're going to react together is going to help them predict products and maybe help them make a new type of medication or a new type of paint, right? That is rust resistant or something like that. Okay. Thank you, Jaden, Australia, Jocelyn, Kaylin, Michaela, Danny, Lamont, Ryder. Thank you, Randy. I appreciate you. Thank you, Adrian. Awesome. So 5 types. First one is called synthesis, a synthesis reaction. And this is exactly what it sounds like. A synthesis is a coming together, right? So this is when there are 2 reactants and they combine to make one product, okay? Here you can see it says A plus B, then forms a single compound AB. An example of this is 2 phosphorus plus 3 bromine molecules will produce 2 phosphorus bromide molecules. Okay. Let's see. I have another video for this. I just have to find it. Hang on. There we are. Okay, so here is a synthesis reaction. Okay, I'm going to speed this up. This is there. You can see the purple haze, right? Pretty cool. Pretty cool. Pretty cool. So that is an example of a synthesis reaction. You can see how he mixed two things together and then made that purple gas, right? So next one is decomposition reaction, okay? Decomposition is exactly what it sounds like. It is decomposing or breaking down into two or more substances. So we start off with one reactant and we end up with two or more products, okay? Okay. Thank you, Jaden. Thank you, Adrian, Kaylin, Jocelyn, Danny, Michaela. Thank you, Randy, Lamont, and Ryder. Awesome. Okay. So another video clip. This one's fun. This is elephant toothpaste. Okay, so that is elephant toothpaste. Again, just breaking down the hydrogen peroxide. Okay, fun stuff. Next one is single replacement. So with a single replacement, okay, we have a metal that's going to replace another metal or a non-metal replacing another non-metal. Okay. And you can see in the ABC equation where A is by itself on the reactant side, but on the product side, we've got A and C. Okay. Down here, you can see zinc plus hydrochloric acid, and the zinc and the hydrogen swap places. Okay, so that's a single replacement. Only one of the reactants is replacing the others. Okay, thank you, Australia, Jocelyn, Jaden, Danny, Lamont, Michaela. Thank you, Kaylin and Ryder. I appreciate you. Okay, Randy, you good? Yeah, perfect. Yay. Okay, last one is double replacement. And double replacement is we have two reactants and two products, and they switch partners. They switch partners. Okay, so that is a double replacement. Okay. Ayani, hello, we missed you. So glad you're here. No, I gotcha. No worries. No worries. Perfect, perfect. I think this is our last question, though, I have to say. Oh, no, we're almost there, though. Yep. Sorry. Okay. Thank you, guys. Thank you, Adrienne, Jaden, Australia, Jocelyn, Kaylin, Danny. Thank you. Thank you, Randy, Lamont, Ryder, Michaela. You guys rock. Okay. Last type of reaction is a combustion. A combustion reaction. Combustion is just another name of burning, right? It's just another name of burning. Okay. So, yeah. Anytime you get heat and light with carbon dioxide and water, you have a combustion reaction. Okay. Thank you, Ayani and Jaden, Kaylin, Jocelyn, Australia, Danny, Randy, Lamont, Ryder. Thank you, thank you, thank you, Adrienne, Michaela. Thank you. Okay, I have a fun combustion for you. This is death of a gummy bear. Okay, here we go. Okay, so we had actually two reactions there, right? He decomposed or had a decomposition reaction where he broke down potassium chlorate so that he made a really, really rich oxygen atmosphere. And remember that we need lots of oxygen in order to burn anything, right? Then he took the gummy bear, which is sugar, right? C6H12O6, and dropped that gummy bear down in that rich environment of oxygen. And it was hot, it was heated up, and lo and behold, that sugar caught fire and combusted into carbon dioxide. That was the smoke you saw coming off, and the flash of light, and some of the water vapor also was coming off. So that's a combustion reaction. Okay. So you will always need oxygen in a combustion reaction, and you'll usually get carbon dioxide and water. Okay. So now, last question on your notes. Last question on your notes is match the types of the reactions to their definitions. Remember, all you have to do is go back to the previous questions, starting with question 14, and you can just match them pretty easy because you've got the definitions right above it, right? So let me know when you are finished with question number 19. Yay, Danny. Thank you, Jaden, Australia, Adrian, Michaela, Danny, thank you, Randy, Lamont, Ryder, Jaden, thank you, Ayani, Jocelyn, Kaylin, you doing okay? Perfect. Perfect, perfect, perfect. Yay. Awesome. Okay. So we defined what a chemical reaction is. We talked about the components of a chemical reaction. We have reactants that make products. One of our reactants are going to be a limiting reactant, right? That's going to limit how much of the product we can make. And then we explained the difference between endothermic and exothermic chemical reactions, and defined the 5 types of chemical reactions. So if you are feeling pretty good with all of that,